So for this week's experiment, you are going to build a balloon car, or in my case, a balloon sled. And then you are going to see how Newton's second law applies to this balloon sled. So we know from Newton's first law that objects only accelerate if there's an unbalanced force acting on them. And Newton's second law predicts how much the object will accelerate. And we know that the amount of acceleration depends on the net force acting on the object, as well as the mass of the object. So once you build your balloon sled or balloon car, you're going to choose, do you want to test how changing the mass is going to affect its acceleration, or how changing the net force is going to affect its acceleration? So the way a balloon car works is you blow it up, and when you let go, all of that air that's in here is going to get pushed out of the balloon and out through the straw. The reason why the balloon deflates when you let go is because this stretchy balloon really wants to go back to its original shape. So as soon as you give air some space to leave, the balloon pushes the air out and it goes out through the straw. Now, Newton's third law tells us that for every action or every force, there is an equal and opposite reaction force. So when the balloon pushes the air that way, the air pushes the balloon that way. So since the balloon is attached to your car, you actually end up getting a force on your car going the opposite direction of the air. So balloon pushes air that way, air pushes balloon that way. So if we want to be testing Newton's second law here, we're either going to change the force acting on the car or the mass of the car. Now, adding mass would mean adding something to it, maybe adding more coins. If you'd like to test the variable of force, then you're going to adjust how many breaths you give it, because the more breaths, the more air is in there. The more air that you get to push out means the more air that's going to push back. You want to find as smooth a floor as possible in order to do these tests. That's because if you use something like a carpet or a rug, you're probably going to get a lot more friction than if you used, say, hardwood floors or tiles, something like that. So once you find your space, you're going to need some tape or sticky notes to mark your different trials, as well as some sort of measuring device. I'm using measuring tape this time. So here's my setup. I've marked one line on my floor that's always going to be my starting point, and I've got my tape measure beginning right at that starting point. Now the tape measure on this one includes inches, but remember we use metric in science, so I'm going to be using the centimeters to measure my ultimate distance. Also, remember that whatever direction the air comes out is the opposite direction of where your car will move. So if you start like this, your car or sled is actually going to go backwards. So make sure that your balloon is pointed where you're headed and that your straw is pointed behind. My balloon kind of went sideways, which makes the distance traveled kind of hard to tell. I'm going to see if I can create more of like a track for it. So I'm noticing that it's tending to turn right, which means that the forces are unbalanced and pushing it more towards the right. So I'm thinking it might be because my balloon straw is actually a little bit crooked. So I'm going to try taping that on a little more straight. And just like with all of these experiments, if you run into trouble, don't hesitate to reach out to your teacher for some help. And remember, the whole point of this is to get some practice thinking about Newton's second law and some practice running an experiment. So if it's not working out perfectly, don't get discouraged. I mostly care about how you set up your data table as well as your explanation of the results that you got. Good luck and have fun.